Hi, welcome to the video on how to draw Bohr models. So in this video I'm going to go over the first of each examples on how to draw Bohr models. Before we begin, I want to go over the Bohr model rules. Now first of all, when I say a Bohr model, what am I talking about? It is one of the models that is used to describe an atom. It shows the nucleus in the center, and then the electrons are located in shells which are around the nucleus. So how do we draw a Bohr model? Well, first step is to determine the number of protons, neutrons, and electrons in your atom. The next step is to draw the nucleus in the center, and in the nucleus you're going to put the number of protons and neutrons. Once you have that, you're going to draw the correct number of shells around the nucleus. Now the number of shells will equal the period the element is in the periodic table. And remember, the period is the row. Finally, we're going to fill the electrons in the shells, and there's some rules for filling. So when you fill electrons in the shells, you're going to fill from the inner to the outer. Now the first shell can only fit 2 electrons max. The second shell can fit 8 electrons max. Now the third and fourth shells, we're going to learn more about that when we go into electron configuration. They technically can fit more than 8 electrons, but we're going to just aim for 8 electrons. They're okay for the ones that we're going to do for our Bohr models. This is one of the limitations of Bohr models. You kind of need to know more about electron configuration to fill up Bohr models of elements beyond calcium. So calcium is pretty much where we're going to stop. Because you need to know about electron configuration rules to do the rest. But anyone between 1 and 20, these rules work okay. Alright, so let's go ahead and get started. Alright, so in my first example, I have beryllium 7. So I want to determine the number of protons, neutrons, and electrons. Let's start with protons and neutrons. Remember, protons and neutrons, we're going to get that from the atomic number for our protons, and for the number of neutrons we'll use the mass number to determine that. Okay, so our protons here for beryllium, you look in the periodic table, find the atomic number. It's here, 4. So that means we have 4 protons. And since this is already sort of drawn for me, I'm going to just draw that in the center here. So the darker circle, that will be my nucleus. Now to get the number of neutrons here, I'm going to take the mass number, which is 7, and I'm going to subtract from that the number of protons, or my atomic number. So my number of neutrons here will be 3n. Alright, so let's sort of recap. My number of protons is my atomic number. And my number of neutrons is equal to atomic number, mass number minus atomic number. So mass number minus atomic number. Okay, so now that I've got that, now I can go ahead and put in my electrons. Now, for these, because no charge is given, I can assume that it's neutral. So that means that the number of electrons will equal to the number of protons. So in this case, I have 4 electrons to put in, so let's go ahead and put them in. Now the rules state I got to fill them in from the inner shell, the shell closest to the nucleus, to the outer, and the first shell can only fit 2. So I'm going to go 1, 2. So in this case, because there can only fit 2, I pair these up. Now I'm going to go to my next shell. Now my next shell can fit 8 here. So the thing is, when we're filling, we're going to sort of get used to doing this. We're going to fill each corner. 4 corner gets 1 before you double it up. Since I have 2 more to put in here, 1, 2. Now it doesn't matter where you start or which direction you go in. Sometimes some people like to go in a certain direction or do it a certain way. I don't quite care, as long as each corner gets 1 before you double up. Alright, that's the Bohr model for beryllium 7. Alright, the next question is asking how many valence electrons. When we say valence electrons, we're talking about electrons in the outermost shell, the shell furthest from the nucleus. And in this case, I only have 1, 2 electrons there. Okay, So you should try to do it for silicon 31 and for magnesium 24. And you can check your answers in the answer key. All right, so you can check it as you go. Remember, we start by using the atomic number for silicon for our number of protons. To get the number of neutrons, we're going to do 31 minus the atomic number. And if you look at the periodic table, the atomic number of silicon is 14. So 31 minus 14 will give us the number of neutrons. And my number of electrons will equal my atomic number because it's neutral. And you'll repeat that same process for magnesium. Pause the video now, check your answers, and when you press play again, we'll be on to the next step. All right, so now for the next one, we're going to go into drawing the Bohr model for sodium-12. So this is pretty much similar to the one we did before, except for now you have to draw the nucleus and the electron shell. Let's start off with getting the number of protons, neutrons, and electrons. So once again, the number of protons is going to equal the atomic number. So let's go ahead and look in our periodic table. Here's sodium. So it has an atomic number of 11. That means I have 11 protons. Now, the next thing it says for us to determine the number of neutrons. And the number of neutrons will equal to the number of the mass number, which is 12 here, minus the number of protons. So this is a very strange molecule because this one only has one neutron. And if you look at the ratio of protons to neutrons here, you probably would know that this is not a very stable atom. But hey, that's what we have. All right, now we need the number of electrons. So the number of electrons, since it's neutral, will equal the number of protons. So the number of electrons here is equal to 11. Okay, so I've got all my pieces. Now I just need to start drawing my Bohr model. All right, I'm going to start with my nucleus. I'll draw that in purple here. And that goes to the center. And all I have to do is just write the number of protons and neutrons in there. So 11p and 1n. Cool. Okay, now I need to draw my electron shells. So the number of shells I need will depend on where sodium is in the periodic table, which period is in. Remember, periods are row. This is the first row, second row. Sodium's in the third row, so that means I need to draw 3 shells. One, 2, and 3. So these are my electron shells in green. Okay. All right, now I have 11 electrons to fill in. So once again, we start from the inner to the outer. And I do 1, 2, that's my first 2. Then my next one, I've used up 2, I have 11. I had 11, so I need to have 9 more. So let's put in my next group, 11. So then this is going to be 1, 2, 3, 4, 5, 6. Remember, each corner gets 1 before I double up. Then we go 7, 8, 9, 10. All right, I have 11. I have to add 1 more, and 11 goes in the outer shell. So just to remind you, we start with the inside. We fill 1, 2. I double these up automatically because the shell fills with 2. Then the next shell, I can put my next 8. I give each corner 1 before I double up. And I had 10 electrons, and then I put my last electron in the outermost shell. All right, so then the question is, how many valence electrons do I have? Valence electrons is the number of electrons in the outermost shell. That would be a 1. All right, so try some more problems. We're drawing the Bohr model for hydrogen 3 and phosphorus 31. When you press play again, we will go on to the last example. All right, in these last examples, we're sort of just doing the same thing we did before, except for in this case, we're dealing with ions, cations, which have positive charges, and an anion here. So remember, with we're going to now need to calculate the number of electrons. Okay, so number of protons, it's still the same as the atomic number, which in the nuclear symbol is the bottom number, 12. And the number of neutrons is going to be the top number minus the bottom number. So the mass number minus the atomic number, which is 23 minus 12. And so my number of neutrons here will be 11. Now going on to the trickier part, which is the number of electrons. Remember that you can either do the charge, so the number of the atomic number minus the charge will give you the number of electrons. So 12 minus positive 1. Or what you can do is you can do it mentally. If you have a +1 charge, that means you have more protons than electrons. And so that means you would have one less electron. So either way, so if you want to do the equation, it will be 12 minus 1, and that means we have 11 electrons. All right, now that we have our, not 12, made a mistake here. There's an error here. This one should be magnesium, not sodium. Sorry about that, because magnesium has an atomic number of 12. So that's magnesium. Okay, all right, so now with that being said, we're going to draw a Bohr model for magnesium. We'll start with our nucleus in the center. And we've got 12 protons. And we've got 11 neutrons. Now we need to draw the right number of shells. Magnesium is in the 3rd period, so we need 3 shells. Fill from the inner to the outer. First shell can fit 2, so we go 1, 2. The next shell, we can fit 8. Again, remember, give each corner 1. It doesn't matter where you start. Let's go clockwise this time. So 1, 2, 3, 4, 5, 6. Now I can start doubling. 7, 8, 9, 10. And then I have one more electron to put out, put it on the side here. All right, and so once again, I have 1 valence electron. Okay, so just to recap for these problems, the number of protons is your atomic number, which is the bottom number. Number of neutrons is the top minus bottom, so mass number minus atomic number. The number of electrons, you're going to take the atomic number and subtract from it the charge. In the case where you have a negative charge, when you're subtracting a negative, you're adding essentially. So just keep track of that. All right, then we do the same process. We draw our nucleus in the center with our number of protons and number of neutrons. And then we draw our shells, which equal the number of periods or rows that the element is in the periodic table. We fill electrons from inner to outer. First shell gets to a maximum of 2. The next shell we can put a maximum of 8. And we don't start doubling until each corner gets 1. And the last shell, whatever we have left goes there. Okay. I hope you found this helpful. So once again, you can check your answers to the others and come in if you come in with questions. Alrighty, folks, have a quality day.